When you use a remote control to change channels on your TV, your remote is using light waves. But this light is beyond the visible spectrum of light you can see. Back in 1800, William Herschel conducted an experiment measuring the temperature changes between the colors of the spectrum, plus one measurement beyond visible red. When that thermometer registered a temperature warmer than all the other colors, Herschel had discovered another region of the electromagnetic spectrum: infrared light. This region consists of short wavelengths around 760 nanometers to longer wavelengths about 1 million nanometers, or about 1,000 micrometers in length. We can sense some of this infrared energy as heat. Some objects are so hot they also emit visible light, such as a fire. Other objects, such as humans, are not as hot and only emit infrared waves. We cannot see these infrared waves with our eyes alone. However, instruments that can sense infrared energy, such as night vision goggles or infrared cameras, allow us to see these infrared waves from warm objects like humans and animals. Infrared energy can also reveal objects in the universe that cannot be seen with optical telescopes. Infrared waves have longer wavelengths than visible light and can pass through dense regions of gas and dust with lower scattering and absorption. When you look up at the constellation Orion, you see only the visible light. But NASA's Spitzer telescope was able to detect nearly 2,300 planet-forming disks in the Orion Nebula by sensing the infrared glow of their warm dust. Each disk has the potential to form planets and its own solar system. Incoming ultraviolet, visible, and a limited portion of infrared energy, together sometimes called shortwave radiation, from the Sun drives our Earth system. Some of this radiation is reflected off of clouds, and some is absorbed in the atmosphere. Larger aerosol particles in the atmosphere interact with and absorb some of the radiation, causing the atmosphere to warm. The heat generated by this absorption is emitted as long-wave infrared radiation, some of which radiates out to space. The solar radiation that does pass through Earth's atmosphere is either reflected off snow, ice, or other surfaces, or is absorbed by the Earth's surface. This absorption of radiation warms the Earth's surface, and this heat is emitted as long-wave radiation into the atmosphere, which allows only a small amount to radiate out to space. Greenhouse gases in the atmosphere, such as water vapor and carbon dioxide, absorb most of this emitted long-wave infrared radiation, and this absorption heats the lower atmosphere. In turn, the warmed atmosphere emits long-wave radiation, some of which radiates towards the Earth's surface, keeping our planet warm and generally comfortable. The energy entering, energy reflected, energy absorbed, and energy emitted by the Earth system constitutes the components of the Earth radiation budget. A budget that's out of balance can cause the temperature of the atmosphere to increase and eventually affect our climate. For scientists to understand climate, they must also determine what drives the changes within the Earth's radiation budget. The Ceres instrument aboard NASA's Aqua and Terra satellites can measure the reflected shortwave and emitted long-wave radiation into space accurately enough for scientists to determine the Earth's total radiation budget. Other NASA instruments monitor the changes in other aspects of the Earth's climate system, such as clouds, aerosol particles, or surface reflectivity, and scientists are examining their many interactions with the energy budget. A portion of solar radiation from the Sun that is just beyond the visible spectrum is referred to as near-infrared. Scientists can study how this radiation reflects off the Earth's surface to understand changes in land cover, such as growth of cities or changes in vegetation. Our eyes perceive a leaf as green because wavelengths in the green region of the visible light spectrum are reflected, while other visible wavelengths are absorbed. Yet the chlorophyll and the cell structure of the leaf are also reflecting near-infrared light, light we cannot see. This reflected near-infrared radiation can be sensed by satellites, allowing scientists to study vegetation from space. Using these data, scientists can identify some types of trees, can examine the health of forests, and can even monitor the health of vegetation, such as forests infested with pine beetles or crops affected by drought. Studying the emission and reflection of infrared waves helps us to understand the Earth system and its energy budget. Near-infrared data can also help scientists study land cover such as changes in snow, ice, forests, urbanization, and agriculture. Scientists are beginning to unlock the mysteries of cooler objects across the universe, such as planets, cool stars, nebulae, and much more, using infrared waves.